Welcome, ladies and gentlemen, to Lesson 9.1, where you can write an algebraic expression to determine any term in an arithmetic sequence. This is something you'll look at again in algebra in 8th grade, and it's definitely something you've seen before, but maybe not with this vocabulary. So, as usual, let's start by making sure we understand the words. Algebraic expression. Anytime we see algebra, that's the branch of math that uses variables in place of numbers. So you know that we're going to be using variables today. Determine term. Term is another word for a number. And an arithmetic sequence is what you'll learn on the next slide. Take a look at this box here, considering the following pattern. So we're looking at sequences now, and we're going to find out what that means. So noticing a pattern, we're looking at making triangles out of toothpicks. What we notice is that one triangle takes 3 toothpicks, 2 triangles takes 5 toothpicks, and 3 triangles take 7 toothpicks. So what do you notice about that? Like, what could we say about as we make more triangles, what happens with the toothpicks? And not just that they're going up, but being more specific, that they are going up in a pattern, which now is known as a sequence. So a sequence is an ordered list of numbers. And bear with my stylus, please. Okay? And what we call them in each sequence, we call each number in a sequence a term. So each number in a sequence. And then what we're looking at today is arithmetic sequence. What an arithmetic sequence is, it's a sequence of numbers in which the difference between each term is the same. So the difference between each term, between consecutive terms, meaning one after the next, is the same. So for example, in this situation, I'm going to scroll up and do this at the top just because I'm running out of room. In this situation, we have 3, 5, 7, and it's going to go on from there. So these are each terms. 3 is the first term, 5 is the second term, 7 is the third term. What we notice is that the difference, the change in the numbers, is that it's going up by 2. This is obvious to us, but if it weren't, difference means subtraction. How you could check is do 5 minus 3, which equals 2, and 7 minus 5, which also equals 2, because that's you finding the difference. So we're going to be asked to identify arithmetic sequences. Our directions here say to state whether the sequence 17, 12, 7, 2, negative 3, and so on is arithmetic. If it is, we're supposed to state the common difference. That is what 2 was in our last example. And then we're supposed to write the next 3 terms. So what I like to do is write these out. So I start with 17, then 12, 7, 2, negative 3. So what I do to find the difference, since different is subtraction, I take the second term minus the first term, and I get negative 5. I try again, and I take the third term minus the second term, and I get negative 5. I try that again, and I do the fourth term minus the third term, negative 5. And just to be safe, the last term here minus that fourth term, and I get negative 5. So what that means is that every time I have a common difference, it's like I'm subtracting 5 or really adding a negative 5, since we think of arithmetic sequences as adding something. So what we say is that the common difference here, the common difference of the sequence is negative 5. And so since the same thing's happening every time, So this sequence, excuse that writing, is arithmetic. The directions also ask us to find the next three terms. So what we would do, we have this, we know our pattern is going down by 5. So what we do is simply just subtract 5 again. We get to negative 8. Add a negative 5 or subtract 5 again. Negative 12. 13, excuse me. Doing some things too quick, not showing my work. And then again, negative 18. So those are the next three terms of my sequence. All right, check your progress. Why don't you pause here, see if you can try these on your own. Remember that you are supposed to say if it is yes or no to being arithmetic. If it is, you'll say the common difference and write the next three terms. If it's not, you'll just say no and then explain. So let's see how you did. So I write these out. And I look for my common difference. So it looks 6 minus 2 would be 4. So that means 2 plus 4 would give me 6. 10 minus 6 is 4. So that means 6 plus 4 would be 10. 14 minus 10 is 4. So 10 plus 4 would be 14. 18 minus 14 is 4. So 14 plus 4 is 18. So here I say yes, this is arithmetic. This is an arithmetic sequence. Because it has a common difference. The common difference is 4. And you write plus 4 if you want to. Then the next three terms, rewrite those out, would be adding 4. So I'd be at 22. Add 4, I'd be at 26. Add 4, I'd be at 30. So my next three terms are 22, 26, and 30. Another one, I'm going to check my pattern to see if it's an arithmetic sequence. And I look, and I do, okay, the difference here, negative 8 minus 4, and you might need to do some side work here, negative 8 minus 4, or minus a negative 4 rather. Add the opposite, that's negative 4. Check the next one, negative 16 minus a negative 8, that's a negative 8. So since these are not the same, and then again here, this is negative 16, since these are not the same, we would say no, this is not an arithmetic sequence. Because there is no common difference. It's important to justify your answer and not just say yes or no. So make sure you get used to doing that. All right, so now writing an expression to find what the nth term of the sequence of the perimeter of squares 4, 8, 12, 16, then write the next three terms. So when you hear nth term, this is where algebra comes into place. We could make a table here. So it's like can be represented as where the top here is the term, the bottom's the perimeter, And the top is the nth term, or this number of squares, where we get the perimeters 4, then 8, then 12, then 16. Okay, so you can make a table thinking this is your first term, second term, third term, fourth term. So we want to say, what if I way down here, for example, wanted to find the nth term, say at the 100th one, the 200th one. I don't want to continually add my common difference. I want to be able to quickly multiply because repeated addition is multiplication. So what I notice is I'm going to go like this and say, okay, what's happening each time? I'm adding 4 every time. And so repeatedly adding 4 is really multiplying 4 by however many times you want to add it, 4n. So that would be your expression. Then to find the next 3 terms, well, we have up to our 4th term. So then our 5th term would be 4 times 5, which is 20. Then our next one would be 4 times 6, which is 24. And then 4 times 7, which is 28. So the next 3 terms are 20, 24, and 28. And you could use that expression here to find the 100th term if you really wanted to. So try that. Try making a table, finding the common difference, and then writing an expression and finding the next 3 terms. So this represents the term number, or your variable. We usually n right now. You could use x if you wanted. And then this is the number that you get out. So we start with -2, -4, -6, -8, and then so on. This was our first term in the sequence, second term, third term, fourth term. So we look for our common difference. Looks like we're going down by 2 every time. And again, to check that, you can find the difference. That's why it's called the difference, by subtracting the most recent term from the one before it. And you're going to get -2 every time. So your common difference is -2. That means that is what you are continually doing. Repeated adding of -2 is multiplication. So our expression is -2 times n. Wants us to find the next 3 terms. So we'll look for the 5th term. Negative times a positive is a negative. The 6th term. And then the 7th term. So the next 3 terms in our sequence are -10, -12, -14. Another one of these, and now it's fractions, so you need to be patient, and you need to try your best to not give up here. So you still make a table. You see you have a first term of 1/6. Your second number is 1/3. Your third number is 1/2. Your fourth number is 2/3. And then we're going to be looking for our next few terms. Remember, this is your term number, and this is the number you get out. So, to find the difference, remember, we are really going to do, it's kind of like you're saying this, 1/6 plus what number gives me 1/3. So I subtract 1/6. If you have a calculator, fine, but know that it's the same as doing n is going to be equal to 2/6 minus 1/6, common denominator, and we get n is 1/6. You can double check for the next ones, 1/2 minus 1/3, 2/3 minus 1/2. Every time you're going to get this, because your common difference is that you're adding 1/6 to each number. So if we want to find our next 3 terms, our expression is going to be 1/6 times what? Instead of repeatedly adding, we multiply. So our 5th term, multiply, put into fraction form, multiply straight across, we get 5/6. Find our sixth term. Multiply straight across. We get 6 over 6, which is just 1. Our seventh term, 7 over 6, which is 1 and 1/6. So the next three terms from this sequence were 5, 6, 1, and 1 and 1/6. A little bit more, bear with me, you're doing great. So this is what it's called when you're looking to find the nth term. You have your common difference, what it's changing by, and your zero term, the number before your first term. Okay? So if we look here, we're going to write an expression to find the nth term, and then we're going to be asked to find a really big term. So first thing we do is look for our common difference. 13 minus 8 is 5. 18 minus 13 is 5. So each number is going up by 5, meaning our common difference is 5, or plus 5. To work backwards to find our zero term, what goes here is we'd say, what number plus 5 gives you 8? So it's kind of like setting up an equation. What number plus 5 gives me 8? Subtract your 5, and is equal to 3. So your zero term is 3. So, using this, we say, okay, it's our common difference times n plus our zero term. So it's 5n plus 3. Now this is our nth term we want to find. So we do 5 times 1,000 plus 3. So we get 5,000 plus 3 for a 1,000th term of 5,003. Last couple, try these. Again, look for your common difference. This one again looks like we're going up by 5 every time. So to find our zero term, pretend it's f, we can say what number plus 5 gets you 4. Work backwards and subtract. F is equal to -1. So our common difference is 5. Zero term is -1. So our expression is 5n minus 1. Now it wants us to find the nth term when it's 12. So we plug in 5 times 12 minus 1. Get 60 minus 1, which is 59. Looks like I'm going up by 4 here. Looking for those patterns. So what came before -20? What number? We can say g just because g's there. Plus 4 gives me -20. Subtract 4. G was equal to a -24. So that's our zero term. So we have our common difference of 4. Zero term of -24. Which gives us an expression of common difference times the nth term plus our zero term. Adding a -24 is the same as subtracting. Here they want us to find our 20th number in the sequence. So instead of adding by 4 20 times from -24, that sounds daunting, we just plug in and we evaluate. So then we end up with 56. The 20th term is 56. Try this one. Let's look it over. Which expression can be used to find the nth term in the following sequence where n represents the number's position? So you do the same thing, except now you're given multiple choice. Look for your pattern. Decide what your common difference is. Then your 0 term would be over here. What number plus your common difference, which is 2, would get you there? Hopefully you know that it'd be plus 1 for an answer C. Hopefully you realize you've done things like that before. You've looked for patterns. You can add, you can multiply. You have all the prerequisite skills. Now we just need to understand the vocabulary and follow directions. Good luck.